Now our motto determine current in 2 ohm resistance, magnitude and direction. Direction means direction of current is B to D or D to B. And what about current in this branch? Okay. So how can we determine? With the help of Thevenin's theorem. Okay. According to Thevenin's theorem, if you determine current in this branch, first of all this one remove. Okay. After removing the circuit look like, first of all make the circuit again, that is 6 ohm, that is 3 ohm, and again that is 6 ohm, and that is 3 ohm. Clear or not? And A to C, this one represent like, okay, clear or not? That is 4.5 volt. Very simple. First of all make the circuit like this one. Our motto determine that is D and that is B. Okay. So first of all load is removed and then determine VTH. Okay, between B and D. Okay, this one is positive terminal and that is negative. Okay, so first of all we have determined current in this branch, and after that current in this branch. Okay, if taken here I1, here I2 current. I1 direction of current, polarity like this one, this one, this one, and here this one. Okay, first of all determine current in this branch, and after that current determine in this branch. After that apply KVL in this loop, determine VTH. Clear or not? So how can approach? How can do it? First of all apply KVL in this loop. So we got minus 4.5, here positive, here negative, that's why minus 4.5 plus 3I1 plus 6I1, this is equal to 0. So what about I1? I1 is 4.5 by 9, that is 0.5 ampere. Okay, similarly same thing here, apply KVL in this loop. Minus 4.5 plus 6I2 plus 3I2, this is equal to 0. So I2 is written as 4.5 divided by 9, we got 0.5 ampere. Clear or not? Now apply KVL in this loop. After that minus 2 plus minus 3I1 plus 6I2 plus VTH, this is equal to 0. So what about VTH? VTH is written as 3I1 minus 6I2. Clear or not? If you determine VTH, that is minus 3I1, okay, plus 6I2, and after that I1 and I2 is 0.5, so 3 into 0.5 minus 6 into 0.5, that is finally we got, that is 1.5, here 3. Okay, so we got minus 1.5 volt. Clear or not? So VTH is minus 1.5 volt. Okay, now next target is RTH. If you determine RTH, means all independent source reduced to be 0. All independents, this one independent source, okay, independence voltage source 0. Voltage source 0 means short circuit. So that point and that point are same representation. Okay, so first of all make the circuit. Here 6 ohm, here 3 ohm, here 6 ohm, and here 3 ohm. Okay, our motto determine equivalent resistance between B and D, that is B and that is D. Okay, and both are, this one is short circuited, so this one make like this one. It means here A, here C are represent same potential. Okay, both are same potential. It means you can redraw again. Then we got this one. Okay, clear? That is, this one is 6 ohm. So our motto D and here B. Clear? So this one is 3 kilo ohm, here 6 kilo ohm, here 6 kilo ohm, and here 3 kilo ohm. And that point is A and C. Okay, clear? So finally, final representation, that is 2 ohm, that is D and B. So what about RTH? RTH is 4 ohm, clear or not? That is 4 ohm. Okay, this one is written 4 ohm. So final representation of the circuit. What about VTH? Minus 5 volt. It means that is RTH, here RTH, here VTH. VTH is minus 1.5. If you written is plus 1.5 means this one is positive and this one is negative. Okay, and that point is B and that point is D. That point is B and that point is D. So finally, what about RL? RL is how much? 2 ohm. RL is 2 ohm. So what about IL? IL direction D to B. Better to write D to B. Okay. Direction of current D to B. Clear? So IL is written as VTH. VTH is 1.5. That is 1.5 volt. RTH is 4 and that is 2. So finally it is written as 1.5 divided by 4 plus 2, 6. Okay, that is 0.25. We got that is 0.25 ampere is the final answer. Okay, clear or not? So finally, what about direction? Direction of current D to B. Direction of current, direction of current is D to B. D to B. Okay, make it very simple. First of all, determine our motto, determine current in this branch, and what about direction. So first of all, this one is removed, 2 ohm is removed. Okay, determine VTH and after that RTH. Okay, so if you determine VTH, our motto determine VTH means voltage across B and D point. Okay, that is A to C. So this one connect here. After redraw the circuit, we got here A, here C. Okay, look like this one. That is 3 ohm and here 6 ohm. Okay, after removing 2 ohm and 6 and here 3. Okay, now apply KVL in this loop, I1, and we got apply KVL in this loop, we got I2. After that, simply apply KVL in this loop, we got VTH. Okay, VTH is minus 1.5 volt. After that, determine RTH, all independent source reduced to B0 corresponding to BD terminal. Okay, BD terminal. So that is short circuited. If this one is short circuited, then circuit like this one, and we got 4 ohm. Okay, after that, put this value here. VTH is minus 1.5 volt, means direction is opposite. This one is minus, here plus. So IL is VTH divided by RTH plus RL, and we got 0.25 ampere. Okay, what about direction of current? That is D to B. D to B. Here D to B. Make it.